Hey, welcome back. Today we're going to be talking about what binding energy is and how it's calculated for AP Physics C mechanics problems. So first of all, let's talk about binding energy. So it's the amount of energy that it would take to remove an object from the gravitational field of some larger object in the context of gravitational forces. So one way to think about this is if you have an object right here with its initial position, and we want to move it to some very great distance away for its final position over here, how much energy would it take to be able to do that? Now, this lesson is building on ideas that I've just covered for universal gravitational potential energy. There's an equation associated with that I've derived, and I can write it right here. It's this. And so notice a couple of things about this equation. It does have a negative sign in it, and that's not an r squared in the bottom like we have with Newton's universal law of gravitation. That's actually an r. And this u here, this represents potential energy due to gravity, and it's a universal gravitational potential energy, so it doesn't necessarily depend on the Earth. Its reference is infinity far away. So if you need more information about that, I'll put a link to that lesson in the upper right about now. But if you understand that concept, if you understand universal gravitational potential energy, then it's actually quite easy to figure out what the binding energy is going to be. Because if we think about it, we're moving from this initial position to this final position. And if we're just concerned with potential energy, that would be our U final minus our U initial. Except we know we need to sub this in, and let's think about what happens here. So this change is... And let's think about what our R value is going to be. In this final position out here, it's essentially infinitely far away from the Earth. It's not actually infinitely far away, but in effect, it's like if it's infinitely far away from the Earth. So we can just put a badly drawn infinity sign down below. And what do you know about that? What is anything divided by infinity? What do you think? Remember, infinity is just some incredibly large number. So as this number goes up, what do you think happens to the overall fraction of whatever this is? Well, the overall value goes down, right? So if we have an infinity on the bottom, it actually turns out to be 0. So you could say anything divided by infinity is actually equal to 0. So that's one way to think about this. So we've got that UF minus, and then minus a minus, right? So that ends up being a plus. G, M1, M2, and now we need to think about what this radius is. So this is the radius for our initial position between the two masses. Well, what are the masses involved? Well, that's the mass of the Earth, would be like M1 or M2, and then the other mass would be the mass of the objects that we're talking about moving. It's got some potential energy involved that we need to overcome. And so what is the distance from the center of the Earth to the surface of the Earth effectively is what we're talking about here. Well, that's going to be the radius of the Earth. So effectively, this is the binding energy. This is how much energy it would take to be able to free an object from the surface of the Earth and get it removed to essentially infinity away, or you could just say fully freed from the gravitational pull of the Earth. I'm going to do more lessons in this topic here of gravitation and forces, and I've done lessons on an entire year of physics, as well as covered most of the concepts in AP Physics C mechanics. If you have any questions or comments down below, please let me know, and I hope you all have a great day. Take care.